sorry, I thought that was answers. Yes, and Tlantla, you're going to do the first question by yourselves, and then DM answers to Yolanda or myself. Okay, Chadwin, I got a different answer, but maybe I went wrong. I'm looking at Gugu's answer. Gugu, your answer is different to Chadwin's, and it's also different to mine. So all three of us have got different answers. Let's see what everybody else says. So maybe just go back and check and make sure you feel confident that that is your answer. Okay, Amu, you're right. You're right. But you have to simplify it to a single trig ratio. So I got your answer too, but you've got to take it one step further. Okay, Amu? I'm going to go through the answers now, but let's just see if in another minute you can do that. Okay, so Ntukozo, I got that answer, but a different sign to the one that you've given me. Gugu, you have now given me the same answer that Amu got, which is correct, but there's one more thing that we need to do to it. Okay, so I'm just going to put it down on the page just to get ready to start working through this. Okay, so I've waited another couple of minutes, but I'd like to go through this question with you guys now. Okay, let's see this. Yes, we're doing 5.1 non-Jabul. I'm going to go through the answer to this question now. Okay. All right, so that's what you got. Okay, so I got a different answer, you non-Jabulo. So let's just have a look carefully at how we would answer this question, and then, of course, where the marks would be allocated. So when we see minus x, so sine minus x, cos minus x, tan minus x, which quadrant are we working in? That's it, Gugu. Well done. Okay, you've got the right answer. Well, that's the answer I got, Gugu. I hope that's the right answer. We're going to go through this now. So which quadrant are we in if we've got negative x as our angle? What quadrant is that? It's quadrant 4. Yes, 100%. So is tan x positive in quadrant 4? No, it's not, because of our cast diagram. So we want to rewrite that as negative tan x. Okay, we have to rewrite it as negative tan x. That's going to be our first mark. Cos x, we obviously cannot do anything with. And now we come to sine x minus 180. Now, there are two ways that we can think about that particular question. All right. The easier way, in my opinion, all right, is to look at it term by term. So sine x means we are in the fourth quadrant. And when we go in this direction, we've gone plus x degrees. Now, if I've got minus 180, the terminal arm swings in the opposite direction by 180 degrees. So we end up in quadrant number 3. So we've gone plus x in this direction and then minus 180 degrees in the other direction. So we've ended up in quadrant 3. And we know from our cast diagram, we've always got to bear the cast diagram in mind when we're doing trig, we know that sine x is going to be negative in quadrant 3, minus 1. So all of these here are a separate term from the minus 1. They're being multiplied together, and then we are subtracting 1 from that. So our second mark would be on the minus sine x. Then we are going to write minus tan x as minus sine x over cos x. We're going to use our tan identity. And then we have times our cos x times our negative sine x minus 1. Now we can cancel down. So something at the top, something at the bottom. Anything divided by itself is 1. And what's left over is negative sine x times negative sine x minus 1. So that gives us sine squared x minus 1. But they said a single trig ratio. So sine squared x minus 1 is not a single trig ratio because there are two terms. So what we're going to do here is we're going to factorize out, or you could change that 1 to sine squared x plus cos squared x. That would also work. We're going to factorize out the negative, and we're going to write 1 minus sine squared x. And that is going to give us negative cos squared x. And now it is a single trigonometric expression. Yeah, or we can add 360. Absolutely, Gugu. 100%. So if you added 360, you'd be x plus 180, which is the third quadrant. Okay, 100%. Thank you for adding that in. Okay, Nanjabula, oh, you see your mistake. Awesome. Anybody else that made a mistake, can you see where your mistake is now? Have you been able to identify that? So I hope I didn't make any mistakes here, but I don't think I did. Yes, are we all good? Okay, cool, Chadwin. Yes, you left out the sign. Okay, into causal. That's a common mistake in trig. People leave out minuses when they should have them, or whatever the case. I forgot that the tan was negative. Okay. All right. So always bear your cast diagram in mind when you do this. Okay, so your marks here are on negative tan x, and you must write negative tan x before you write negative sine x over cos x. You have to do that. Okay, so everything that I've written here, you have to write. They're very pedantic about trig. You have to show all your steps. You have to show when you've used reduction formulae and what you get. Okay, then the next mark would be on the minus sine x. Then it would be on the tan identity. Then I imagine on the factors over here, and then on your final answer. Okay, let's go and have a look at the second question, which is 5.2. So here they give us the cos of 35 is equal to m, And then without the use of a calculator, determine the value of each of the following in terms of m. All right, so we are doing a ratio in terms of a letter. Okay, so the first thing that they give us is the cos of 215. So how can we use our reduction formulae and 35 and make 215? What can we do here? So remember, we're only allowed to use our reduction formula. We can't make up anything else. There we go. Beautifully put. Well done, Mamelo. 100% in Nhlanhla. Yes, Gugu. Yes, Tsegofatso. Yes, and Ntokozo. Lovely. Okay, so you've all written that beautifully. So the cos of 215 is the cos of 180 plus our 35. So which quadrant are we in, Matrix? If we've got cos 180 plus, which quadrant would we have been in? In the third quadrant. Well done, everybody. Is cos theta positive in the third quadrant? Indeed, into causal, yes. Okay, it is not. It is not positive in the third quadrant. Okay, so remember our cast diagram. So this is going to end up being negative cos 35, which gives us negative m. Okay, so the 2 marks here would be on this line over here. This line, our second line, you don't have to show where you've used your reduction formula, but you have to show what you get after using your reduction formula. But I suppose it's nice just to put it in. And then we can see where our answer comes from, and then a mark on our answer. The second one is out of 3 marks, so that's a little bit more. This is now the sine of 20. So I'm going to let you guys think about that for a minute. How do you think we should approach this question? So we've got the cos of 35 is m, but they want the sine of 20. What do you think we should do? Any ideas? Awami, I like the way you're thinking. So you can't use 55 minus non-Jabulo, unfortunately, because 55 minus is not a reduction formula. So you've got to use a rule or a law or a reduction formula or something. Nhlanhla, very nice. Go for it, Nhlanhla. Go for it, Awami. We'll catch you up. Good. Mamelo. Yes, Pumzile, it is. It is. So I don't know what the rest of you saw, but Pumzile said, is it a co-ratio? Yes, it is. Yes, it is. Okay, so Mamelo, Pumzile, Nhlanhla, and Awami, you were all on the right track. So you guys continue trying it. Everybody else, when we talk about co-ratios, this is the idea. So the sine of 20 is the same as the cos of what? The sine of 20 is the same as the cos of what? It's the cos of, that's it, 70. Okay, remember it's got to add up to 90. Okay, good, well done. It's the same as the cos of 70. And 70 is double 35. Good, well done. So that is the cos of 2 times 35. All right, so sorry, I'm actually doing it over here. And then you could expand that. When you are doing ratio in terms of a letter, it does not matter which of your cosine double angles you use. For some reason, I tend to prefer 2 cos squared theta minus 1, but it doesn't matter. Okay, so we've got 2 cos squared 35 minus 1. Okay, and we know that the cos of 35 is m, so that gives us 2m squared minus 1 as our final answer. Okay, so our marks here would be on the co-ratio using your double angle formula for cos 2 theta, and then on your final answer. The third step. Okay, so what I've done is I'm just using my double angle formula. So in other words, if I have got the cos of, let's say 2 times 10 degrees, what I'm doing here, Pumzile, is I'm using this. So this 2 cos squared alpha minus 1. So my angle is 10. So I would write this as 2 cos squared 10 degrees minus 1. So I just did that with my 35. Does that make sense to you? I was just using this formula over here that I'm putting the orange ring around. Okay, does that make sense? So in other words, I'm expanding my double angle. Okay, and then I am substituting cos squared 35 with m squared. Pleasure, no problem. Okay, guys, hang on, that was, oh yeah, that was out of 3. Sorry, I'm looking at the 4, but that belongs to the general solution. Okay, so let's go and do the general solution. And again, I know they're a little bit small. I'll make them a little bit bigger and I'll pop them underneath there because you may want to have a quick peek at the formulae before we answer this question. So they want us to determine the general solution of cos 4x cos x plus sin x sin 4x equals negative 0, 7. What do you think's going on here, Matrix? What do we have on the left-hand side? What do you think it is? Indeed. Good, Amu. Good, Gugu. Okay, maybe you just made a typo, Matle, but it's a compound angle. Okay, what sort of compound angle is it? That's it. It's a compound angle for cos. Good, well done. So if we look at our cos compound angles down here, we know that cos cos goes cos, right? So we've got this one over here, or we've got that one over there. All right, so we're looking carefully at this and we can see that there is a plus in the middle. So if there is a plus in the middle, it has to be the one on the right. Okay, so that's it. Well done. So now we have to say cos. So when they give us the expansion, we want to do the reversal of that expansion. So we're going to write cos 4x cos x plus sin x times sin 4x as cos 4x minus x is equal to negative 0, 7. So that would give us cos 3x equals negative 0, 7. Is everybody okay with that? Right, so I did the reversal of the expansion. So in other words, I went like that, went back the other way. Good. And now that I have good, good. All right, everybody's happy with that. Lovely. Now that I have cos 3x equals a ratio, now I can find my reference angle, my key angle. Um, at my school, we like to call that a PAA, a positive acute angle. Okay, so that reminds us that it needs to be positive and it needs to be acute. So we do not use the sign when we are calculating the ratio. What are you guys getting as your key angle? That's it into causal. I'm getting the same. Yes, Awami. Nhlanhla, careful, don't use the negative. Okay, remember it's got to be an acute angle. Yes, Amu, that's perfect. Okay, so it's going to be 45, comma 57 degrees. You don't use the negative to calculate. How did I get the 3x? From 4x minus x. So 4x minus x is 3x. Does that make sense, Mbele and Claire? Okay, all right. Now we use the sign, the negative. So remember, again, we are referring to our cast diagram. Our ratio is negative. So in which two quadrants is cos x negative? Quadrant 2 and quadrant 3. So that's where we have to do our solutions in quadrant 2 and quadrant 3. That's it, Gugu. Okay, so for quadrant 2, we are going to take our angle 3x and let it be equal to 180 minus our PAA. And then remember, because we're doing a general solution, we're going to say plus k times 360. K is an element of the integers. All right, and then we can go ahead and go and solve for x. So that would be 180 minus our 45.57. And then we've got to divide our answer by 3. So here I'm getting 44.81 plus k times 120. K is an element of the integers. Okay, so Kalipa, on your calculator, you are going to go shift cos, and then you're going to put in the 0.7. Okay, if you want me to pull up my calculator, I can do that. Just let me know. Or we have to work in quadrant 3. And in quadrant 3, we would say 3x equals 180 plus our PAA plus k times 360, because remember the period of a cos graph is 360 degrees. So now we have to add our PAA to 180, and then we're going to divide through by 3. So here I'm getting 75.19 plus k times 120. Yes, you only have to write k as an element of the integers once into causal. I'm just in the habit of putting it on every line, but it only does need to be there just once. Okay. All right, Kalipa, you all good now? Is everybody happy? Are there any other questions? And then I'll show you where the mark allocations would be. Okay, so There's going to be a mark for doing the reversal of the expansion. There is always going to be a mark on our final answer, and then there would be another mark for working in the correct quadrants. So this one is out of 4. Is everybody happy with that? Yes. Okay, good. So as far as general solutions go, oh, good. It's nice to see all the thumbs ups. Good. Well done, everybody. So as far as general solutions go, that one wasn't too bad. Let's hope we get a reasonable one like that this year as well and not something nasty. So what they've done this particular year is they made the general solution a bit simpler, and now they've made the identity a little bit harder. Okay, so let's tackle that next. I'm just going to write it down in the meantime. You guys can do the same. So we've got sine 4x times cos 2x minus 2 cos 4x times sine x times cos x, and all of that is over tan 2x. So we are supposed to put in their left-hand side equals, and I think that's where we'll start. Incidentally, I know that our identities are here on the board. What is the right-hand side equal to? So cos squared x minus sine squared x is what? What do we know about that? What's it equal to? Aha. So that's equal to cos 2x. So we know that we have to simplify. Good, well done, everybody. So we know that we have to simplify the left-hand side to cos 2x. That's what we're looking for, isn't it? Because then we can just rewrite it as cos squared x minus sine squared x. So that's what we've got to do. All right. So let's go and have a look at this a little bit more closely. Let's move this guy down. Oopsie. Sorry, everybody. And let's scrutinize this a bit closer. Okay, so we've got sine 4x cos 2x, and then we've got minus 2 cos 4x sine x cos x, right, over tan 2x. So we can't cancel terms. It doesn't look exactly like a compound angle, but we've got the sine 4x cos 2x. So it kind of does look a little bit like a compound angle, but they've just done something here. They've just manipulated it in a funny way just to kind of throw us off a little bit. Can anybody spot where our starting place needs to be? Does anybody? It's in the second term of the numerator, so I'll give you a hint there. Where do they actually want us to start with this question? Any ideas? Okay. Ah, yes, Nhlanhla, you're quite right. Okay, so Nhlanhla, you go for it. You see what you do with that. And I'm just going to talk a little bit more to everybody else. Okay. So they've been a bit mean in this particular question. All right. Can you see you've got sine 4x cos 2x, and then over here you've got cos 4x. So it's kind of looking like a sine compound angle. But the part where they have been a bit sneaky here is they've got a 2 over here, and then they've got sine x cos x over there. So when we multiply matrix, does the order of multiplication matter? Does the order in which we multiply matter? No, it doesn't. No, it doesn't. So we can rearrange things and we know that we'll still get the same answer. So what we're going to do is we're going to leave the sign 4x times cos 2x, our first term in the numerator on the left. And what I'm going to do is I'm going to bring that cos 4x to the front and I'm going to move the 2 into the middle. Now what do you see in the second term in the numerator? What can I do with the end bit? What can I do with this? It's sine 2x, isn't it? Ah, so now look at your first two terms and now what your second two terms are going to be. Can you see that it is making a sine compound angle? So we've got sine 4x times cos 2x minus cos 4x times sine 2x. And all of that is over tan 2x. Are we all happy so far? Yes. Oh, good. All right. Lovely. Yes, Amahle, go for it quickly.
Evening, ma'am.
Good evening, Amahle.
Why did we move the 2 to the over to sine x times cos x?
Because then we can make sine 2x if we do that. Because remember,
Okay.
sine 2x is 2 sine x cos x. And if we have a look at our compound angles, all right, then we want our sine 2x to be 2 sine 2x because it's going to go with the cos 2x is going to make our compound angle for sine.
Okay.
Does that make sense to you?
Yes, that does. Thank you so much.
Okay, all right. So if you have a look up at the top here, remember sine keeps its sign. Okay, so sine keeps its sign. All right, Amu, I am going to go through it again. All right, Nhlanhla. Sorry, just give us a second. We're a little bit behind you. Okay, so what we've now got is this situation. So our right-hand side, this is now what we've got in the numerator. On our right-hand side, we've got sine alpha cos beta minus cos alpha sine beta. Okay, so they really were testing compound angles this particular year. And again, they want us to go from this situation and do the reversal. Okay, so that means that we are going to end up with sine 4x minus 2x all over tan 2x. Sorry, this is just the one that we've done. Why that's there again, being silly. Okay. And now we can simplify. This gives us sine 2x over tan 2x. So now we would write sine 2x divided by, and remember tan 2x is sine 2x over cos 2x. Now we've got to work with fractions. So this gives us sine 2x times cos 2x over sine 2x. Divide sine 2x at the top with sine 2x at the bottom. And there we go. That's what we said we needed. We said we needed cos 2x, didn't we? And that would give us cos squared x minus sine squared x. And it would therefore be equal to the right-hand side. Okay, so Amu, I know I lost you somewhere. All right. So what I was doing here, Amu, I'm just going to move it up and then I'll move it down again, everybody, is I was trying to make a compound angle. So I moved the 2 into the middle so I could have 2 sine x cos x. And from the 2 sine x cos x, I got, I'll just show you, I then wrote that as sine 2x. Okay, so on this line here in the numerator, I have got a sine compound angle. And then I did the reversal. So this over here is the reversal of the sine compound angle. And then I used my tan identity, tip and times or keep flip change, and got to my cos 2x like so. Yes, absolutely. You can move, so you can move it around, Amu, because it doesn't matter in which order you multiply. So if I write 2 times 3 times 4, but you decide you need 3 times 2 times 4, there's nothing wrong with that. Okay, so you're moving things around within a single term where you're only multiplying. Okay, so you are allowed to do that. Does that make sense? So you're not breaking any mathematical laws. So these are the sorts of things that they will give you to sort of make it a little bit more difficult. All right, so they can pull things apart like that and move the factors and put them in different orders, but you can move them back again. Okay, and manipulate them. Is everybody happy with this particular question? Yes, it's Tehofatso, Mamelo, Cameron, Gugu, Lebuchang. Good. All right. So just quickly, it was out of 4 marks. It's quite a lot of writing for 4 marks. So let's see where we would have been given marks. So we wouldn't have been given marks for moving something, but we would have definitely been given marks for writing 2 sine x cos x is sine 2x, a mark on our reversal, a mark on our tan identity, and then I suspect a mark on the cos 2x as well. Okay, we wouldn't obviously get a mark on the answer because the answer is given to us in that particular question. Okay, all right, so let's go down and go and have a look at this particular question. So what I'm going to do here is I'm actually going to start with question 5.3, and it doesn't matter because 5.3 is a separate question from 5.2 and 5.1, and I'm doing that with you because I want to do something that is just a little bit more difficult. Okay, so we've got some time now. I just want to try this question with you guys. So in 5.3, they give us sine p plus sine q is 7 over 5. Then they tell us that p plus q is 90. Now that's really important. Without using a calculator, determine value of sine 2p. And it's out of 5 marks. So I'm going to give you guys a minute or so to think about it, and then you can tell me what you think and where you think we should start. So the P plus Q is critical in this case, the fact that it adds up to 90. So I'm trying to drop some hints here. Yeah, so in this particular case, yes, our special angles are not going to come into this particular question. You're right, Amu. Yeah, so there's no special angles in this particular question. We would have used special angles in question 5.2, but not in question 5.3. Intercausal, that is true, but rearranging it like that for this particular question actually doesn't help us. What we need to understand is that when they tell us what P plus Q equals 90, what does that actually mean? What sort of triangle are we working in? If P plus Q equals 90, then what sort of triangle are they applying this trick to? Yeah, it's a right angle triangle. Quite right. Yeah, a right angle triangle. Okay. Not that you need the right angle triangle. There's a quicker way to do this. But I tell you what, let's start there, right? So I'm just going to draw a right angle triangle here just to help you guys visualize this problem. And it doesn't matter which one is P and which one is Q. All right. So if we're in a right angle triangle, apart the sum of the other two angles in the triangle has to be equal to 90, right? So if we are working in a right angle triangle and things are adding up to 90, and I'm emphasizing the word 90, what concept uses things that add up to 90? What concept that we've learned about? We've actually mentioned it this evening already. Aha, quite right. Inhlanhla, yes. So we've mentioned it tonight, Lebogang. If you go back in the chat, remember when we did the sine of 20 and we said it was equal to the cos of 70? That's it. Our complementary angles, our co-functions, right? Our co-functions. So if I call that angle over there A, if I am starting at, let me start at this angle over here at Q. The sine of angle Q, the sine of angle Q is going to be opposite over hypotenuse. So that would be AP over PQ, right? But if I work from angle P and I do the cos of angle P, it's going to be adjacent over hypotenuse. So that would be AP over PQ. So our co-functions tell us that the sine of Q is the same as the cos of P. Does that make sense to everybody? Okay, so it's like saying the sine of 60 is the cos of 30, or the sine of 30 is the same as the cos of 60. Does that make sense to everybody? Or the sine of 45 is the same as the cos of 45, or the sine of 20 is the cos of 70, or the cos of 1 is the same as the sine of 89. So cosine and sine can be equal when our angles add up to 90. Right, so the first thing that we need to deduce here in order to solve this problem is that we can write the sine of Q as the cos of angle P, and that is because they are co-functions. Okay, that is the key to solving this particular problem. So can you see they're never testing you outside of what you actually know? You just need to be able to recognize that that's what the question is asking. And that's why that P plus Q was critical in this case. That was them telling you that these are co-functions. Okay, they add up to 90. So that means if P plus Q is 90, it means the sine of Q is the same as the cos of P. Now, we want to work in terms of P because our answer is in terms of P. So we're going to keep the sine P, but we want to change the sine Q. So now we're going to rewrite our equation. The sine of P plus, and I'm going to substitute the cos of P in place of the sine of Q, and I'm going to make it equal to 7 over 5. Now, the next step in the question, all right, is given to us in this sine 2p over here. That's actually where the hint is. Because we know that the sine of 2p is 2 sine p cos p. But this is how they want us to get to that. Would you believe it? But our next step, who knows? Well, actually, instead of me telling you, what do you think the next step is with our pink equation? What do you think they want us to do to both sides of our pink equation? So sine p plus cos p equals 7 over 5. They want us to do something to that to get to sine p cos p. Does anybody know what that is? And any idea? So we can't use any compound angles here, Shreya. I hope I said your name correctly. We'll note that it's a compound angle because we'll see sine of an angle, cos of an angle, plus or minus cos of an angle, sine of an angle. All right, so here what they want us to do, would you believe it, is we have to square both sides. Because when we square both sides, through our FOIL process, we're going to get 2 sine p cos p. So we're going to end up with this. We're multiplying the binomial by itself. And on the right-hand side, we end up with 49 over 25. Now we're going to do FOIL. So we get sine squared p plus sine p times cos p plus cos p times sine p. So that gives us 2 sine p cos p. Is everybody happy with that? Plus cos squared p equals 49 over 25. Are you happy with how I've squared the binomial? Yes. And what is sine squared p plus cos squared p equal to? 1, exactly. So now we've got 2 sine p cos p plus 1 equals 49 over 25. Exactly. So now we can write the 2 sine p cos p as the sine, as the sine 2p that they wanted. And we can take the 1 over to the other side. So we're going to say 49 minus 25. And believe you me, if you do that on your calculator, minus 1, no one's going to know. So it's not going to make any difference. And you would end up with 24 over 25. Okay, and there we have calculated the value of sine 2p. All right, so our marks here would have to be for writing sine q as cos p. Then, in order to get to the answer, sorry, my eye is just itchy. Sorry, Matrix. Oh, scratch that. We would have to square both sides. Okay. I know they're going to give us a mark on the answer. So there's another 2 marks that they would award us here, there would have to be a mark on the 1 and on getting the 2 sine p as well. Okay. Everybody happy with that? Does that make sense? Are there any questions? Yes, Gugu, go for it.
Hi, ma'am.
Hi, Gugu.
So, I see what you wrote, but I'm lost. I am just lost. So from the moment where you squared that equation,
Mm-hmm.
yes,
Is
that's
that where
where
you
I got.
lost?
Yes,
Okay. All right. So are you happy with sine p plus cos p equals 7/5? Does that make sense to you?
yes,
Okay, all right. So the reason that I squared both sides is because I know that when I square sine p plus cos p, I can end up with sine squared p plus 2 sine p cos p plus cos squared p. That's why I did it. Okay. So when you square the binomial, you're just doing FOIL. So in other words, you're saying sine p times sine p is sine squared p. Then you're doing sine p times cos p plus cos p times sine p. So those are two like terms. So that's why you get 2 sine p cos p. Does that make sense?
yes, it does.
Okay. And then your plus cos squared p comes from last times last. All right. Then in the next step, I am taking sine squared p plus cos squared p, and I know that those two together give me 1. And 2 sine p cos p is sine 2p. And then I took the 1 over to the other side and I minused it from 49/25.
Okay, I get it, ma'am. Thank you so
Does
much.
that make sense to you?
Yes, it does.
Okay.
Shali, I'm just gonna jump into the next class. Bye, matrix. See
Sure,
you
that's
next week.
fine. All right, I'll see you now. I'm coming. I've got load shedding. All right, so Nhlanhla, you said, isn't sine Q AQ over PQ? No, it isn't, Nhlanhla. Remember, the sine of an angle is opposite over hypotenuse. So it's AP over PQ. Okay, the cos of Q would be AQ over PQ. Okay, Nhlanhla, opposite over hypotenuse.